Hello and welcome to another walkthrough in the Python Absolute Beginner series. This is Module 4, focusing on nested conditionals. This module also introduces the while true loop because the while true loop uses the true or false binary conditional to test whether to continue running or not. So it's pretty cool. We're going to go through a number of things here. We're starting with nested conditionals, and we got to understand what that means. So we'll do that. And ideally, when you get done here, you'll have a sense of how to make your own nested conditional logic. So here, let's go on down. This idea of nested conditionals is like making a sandwich. So if you think about the process of making a sandwich, like down in the sandwich shop, Subway or Boar's Head or where have you, you have to first answer a question like, what bread? Wheat or white? Then they might ask you, well, what meat? And then there's specific options. And then what cheese? You know, manchego or cheddar or provolone or what have you. And then they might ask other questions like toasted or not. And so every time they need the answer to the first question before they can move to the next, which means they're making nested decisions. So to run through that and think about it, we can see this first example here. So first of all, notice it tells you here, review the code, then run it through the different paths. So now click in the input box before typing. Okay, I got all that. So sandwich type equals input C for cheese, V for veggie. This is asking the type of sandwich you want. So we're going to get prompted for a type of sandwich. Whatever we type that gets stored as a string into this sandwich type variable is going to get converted to lowercase and then compared to a lowercase c. So if it matches, then the code right here will run. Now, when that code runs, this is for sandwiches with cheese, right? Because of the lowercase c. And now it's going to ask, what cheese do you want? Do you want cheddar or manchego? And it's going to be a C or an M. It's going to get stored in another variable called cheese type. And then cheese type is going to get converted to lowercase, just in case someone types uppercase. That's error checking. And that's useful when your users might have put something in. You can help them along. That's what we're doing there. And then it's going to be compared against a lowercase c. If it is a lowercase c, it means they want cheddar cheese. And we're going to print out, here's your cheddar cheese sandwich, else here's your manchego cheese sandwich. So you can imagine we might be writing the code to tell a food printer, yes, they exist, or an automated ordering system or something like that, what to do next depending on options selected. This is a very common scenario in code when you're ordering from an online store or anything where a product or service has options that you need to select, and depending on the options, it will cause a different query to the inventory, for example, to see if all the necessary supplies are there or any kind of further business logic. So let's run it and see how it works. So if I run it, I see I get my questions, C for cheese, V for veggie. If I type V and I hit return, it just instantly goes to this else. You see that? It wasn't C here. Anything but C, it's going to say, here's your veggie. I can test that by running this again and typing in and hitting return, and it still says, here's your veggie special. Now, a better way to do this would actually be to say elif sandwich type dot lower equals V. That's where I actually want to print, here is your veggie special. And the other thing we'd want to put here is, sorry, we only have cheese and veggie. So if someone types anything other than a V or a C, we're going to tell them, sorry, we only have cheese or veggie. So we just changed that code to fix it. Again, we're doing error checking for people. I'm going to run it. This time, if I put an in, I get, sorry, we only have cheese and veggie. So we've improved the code. That's cool. Now, nesting is when you have an if statement inside of an if statement. And remember, everything indented after this if, up until the next block of code that's not indented or multiple empty lines, is considered inside of this if condition. So after this colon here, Python knows to look for indented blocks of code that it runs subject to this condition. And within that, it's got another if statement. And so let's do that. Let's run it. And I'm going to put C this time. And now I get another question. What kind of cheese? I'm going to put M. And it tells me here's your Manchego cheese sandwich. So it worked. But you see how we had one decision that led to another question, which led to another decision, which only runs if the first condition was true. So that is nested if statements. All right? And here, actually, you see down below, we just did what it said up above, except they expanded it just a little bit here. They put the sandwich type. So, and now they put a couple of other little things. But you can read through this and understand it. We've essentially just done the same thing. He gave a little welcome, welcome to the sandwich shop. So we've got a pretty good variety of things there that give us a sense of how a nested if might work. Using a nested if, check if it's morning, if not evening, if not, say hello. So here, say hello with nested if, challenge, handle input other than yes, no. So we're asking if it's morning or evening. So let's do using nested if, check if it is morning. Morning equals input is it morning? Answer yes or no. Just to give our user a clear prompt. So we're going to ask our user, is it morning? And we're going to say if morning. So handle input other than yes, no. All right. If morning equals yes, print good morning. Okay. Now, if it's morning, we're going to print good morning. Now it says to use check if it's now evening. Now specifically here, elif morning equals. So here I can handle the in condition. So it's not morning. All right. Now I can say evening equals input Is it evening? Same thing, answer yes or no. We're going to go, I might as well just grab that. Save myself a little trouble here. Like that. Now I can make my nested if, so I can say if evening equals y, print good evening. Now, if they said in, but then they didn't give me a y, I can do else print hello. But actually, if it's not evening, so if it's intentionally not evening, so if evening equals in, we're going to say hello. And notice the bonus there. They said handle input other than y and in. So if they don't say y or in to the evening question, we're going to say print answer evening only with y in. Okay? Now that is for evening. Now if they don't put a y or in for morning, I'm going to do the same thing down here. Print answer, ooh, I need my quotes there. Morning only with y in. And notice I've got to get my other quote over here. Now I can test it out. We've got a procedural program here. I can hit Y, good morning. I can, oops, sorry. I just hit the wrong button. Scroll back down and run it again and do in. Now it's asking me if it's evening, right? Because I put in, and if I hit yes, then it says good evening. Now if I say it is not morning and it is not evening, I get hello. So the functionality's right. I'm looking through here, I can see. And now I want to see if it can handle the case when I don't put in a y or an in. So I'm going to run it again, and I'm going to put in G. Answer morning only with y in. Now I'm going to run it again. I'm going to put in, and I'm going to put a G. Answer evening only with y in. I have done everything including the challenge. And I've used a nested if, right here. There it is. Nested if, testing for false. Use nested if statements, complete the flow chart. There's no real flow chart, so that's not useful, but we can look through and see what's here. Create a bird string variable. So birds with the names of 1, 2, 3 or more birds. So birds equals parrot, jay, what other kind of robin? There we go. Get bird guess. Bird guess equals input. Please guess a bird name. Something like that. All right, use birds in bird guess and bird names, generate true or false. If it's wrong, create a subtest. So we're going to give them 3 guesses. So if bird guess dot lower in bird names, or birds, sorry, I don't have bird names, I have birds. Then print you found one on the first try. So we're making a little game. Okay, that's if they got it, right? So if they got it, if it's not in there, then we're going to make another statement here. We're going to say guess 2 equals input. So this is what happens if they didn't get it right. Sorry, your bird was not found. Try again. They'll get another guess here, and then we'll do an if that says if guess 2 dot lower in birds. And look at what we're doing. I think I can copy and paste here. I'm going to take all of this. I'm going to take all of this right here, and I'm going to hit return and paste. And then I can take all of this and select it and hit tab and bring it all over, because I need the same logic. You found one on the second try. And if they didn't, then we're going to make guess 3. And guess 3 last try. They get a third try. And on the third try, if they get it, finally, you got one. And then we can say else print sorry, no luck today. All right. And then I can run it. Guess a bird name. I'll say J. Oh, bird guess is not defined. Oh, I spelled it wrong. Look at that. Look at that. And the error helps a lot. Bird guess. I'm going to run it again. J. Got one on the first try. Lark. Nope. Now try again. J. Found one on the second try. All right. Now I'm going to say lark. Sparrow. Oh, I'm going to do a capital R. Robin. Finally, you got one. Worked. And I'll just do F, D, G. Sorry, no luck today. There you go. And that's a nested if. You see how each if is subject to the if before it? And so it handles all the different possibilities. You can imagine this is a decision tree, and we're handling all the different possibilities. Okay, escape sequences are kind of interesting. They aren't exactly about nested conditionals, but they are useful. They allow us to do some things that are important for coding. So down here we see that escape sequences start with a backslash, or yeah, that's the backslash, I suppose. Maybe it's, yeah, that's right. And that's a character above the return key on your keyboard typically. The reason we have these is that sometimes we want formatting to not just literally type out the characters, but to actually input some of these important line feed or tabbing behaviors that happen in your keyboard on the tab key or the return key. And the way we do that is essentially by using this backslash to create a special command in effect. And they work with print statements. So if we check this example down here, we see this funky, look at that. See that? Backslash in. Hello world, I am formatting print. Well, let's try it. So if we go back and I run it, I see that I got 2 lines here, right? If I take this character out and I run it, it's 1 line. So I was able to indicate that there's going to be a line here by putting that character. And Python's print function knows to have a special behavior based on that and go ahead and run it. Same thing's happening here. Let's run this. So student name, age, Hiroto Yamaguchi. And see, it's got a tab here, 2 tabs, and the student name happens to be really long, so that would be a whole different set of logic to figure out how long the name is, and that we don't need 2 tabs. There's only 1 tab here. If we put 2 tabs, it will actually jump over even further. See that? So that's a different issue, but we could calculate that by checking the length of the student name and then appropriately adding tabs using an if statement. It's possible. But that allows us to format things to look good, and it allows us then, like quotes in quotes. If we want double quotes inside of a double quotation, do you see how that printed out quotes? If you didn't put this escape key, then Python would think that your quotations were closed, and it would look for a variable named quotes, and it would try to find it inside of itself, which it would if there is a variable named quotes. So for example, if I take this out, you'll see we'll get an error. See that? Invalid syntax. So Python knows there's a problem there. So I'll just come back and put it back in. And let's see, right like that. And that allows it to work, because now we can actually do what we're doing. And you can see how it allows us to literally print out quotes, which we could not do otherwise. Same thing here, where we've got this I've, otherwise we've got single quotes inside, 2 single quotes inside of a string. Python would think that's the beginning and end of the string itself, but because we're using escape characters, Python knows not to think of it as the beginning or end of the string. Now, you can escape the escape itself. So if I want to explain to someone how to do the new line character, you'll notice you can put a double backslash, and when you do a double backslash, it knows to literally put a backslash into the screen. So format using backslash escape slashes, warning. So if I want to print out with 3 backslashes, so let's just try this. What if I print literally? Let me copy this and paste it. Now, if I want to literally print this exact thing, I know for sure that I've got to put in a / right here, a backslash, sorry. And then I'm going to run it. And now I see that I have 2 slashes here. I don't have 3. So I have to add another one here and run it. Oops. Save. Maybe I 1, 2. I want to have 3. Did it not pick it up? Maybe I didn't save it. And run it. Oh, it's doing 2. I need at least 1 more. There it is. So now I know, in order to actually print out this exact message, I've got to escape some of these characters in order to get it to go. I think you can do this next one. I think you're ready for it. Brackets from one print statement output the text commented below using no spaces. 2, 3, 4. Output the text commented below using no spaces. So in other words, use tab characters. So here, just like tabs up above, print this out with use tab keys. All right, pre-word function. A function as a single string parameter checks for a single word starting with pre, so we could actually come down here. We're creating a function. You know what to do, right? You have to use a def keyword. It's going to have a single parameter. The parameter itself, it doesn't tell us what to do. We'll call it the pre-word or the test word. that. Then it's going to check if test word dot starts with pre. That's a true or false. If it does, then we're checking if test word is alpha. So all I'm doing is I'm reading through line by line up here to see if all texts return true. So that's true at this point. And now we're going to return true. If any checks fail, return false. Else, return false. We still need to close the prior statement, so I still need to go down here and return false in case the word didn't start with pre in the very beginning. We still want to return false. Print is explaining is a valid pre-word. So else, print, you need to input a valid. And remember, I got to use an escape character. Pre-word. There we go. There we go. And in the case, I actually need to do that. So I've used my escape characters and test if return value is false. Oh, then we're going to test if the return value is false. Oh, sorry. We're not putting it in right here. So we're going to call it, we're going to say result equals pre-word input. I think I can chain this, but we'll see. I'm put a prompt in here. There we go. Enter a word that starts with, and remember, I got to escape this too. With pre, I like to put a little space there for users, a little easier. See if I can feed that, and then if result. So that means if the result is true, print nice. Else, oh, there. Else, oh, I lost my phrase. So I'll do it again. Please input a valid pre-word. Okay, so if I run that, pre-game, nice. And if I run it again and I put true, it says please input, so it works. Nested if, escape characters, you can kind of see how all these pieces are allowing us to do more advanced stuff, right? This one right here is kind of interesting. This example is a little bit more advanced. It's sort of a peek into the future. It is a lingo we're going to learn in the future, but what's happening here is when you print x 0 to 3, we're actually beginning to learn. We've already been testing components of our strings if you play with this a little, if I change this to 4 and I hit run, oh, what happened? It's now preg. What if I change this back to 2 and I run it? I just want you to think about that for a second. There's a special notation going on here. We're going to get at this more later in the next Python fundamentals section of your learning. But what do you think's happening there? That's just a teaser. This is a little teaser, so something to think about. Fix the errors. If I hit return, I get an error. It tells me unexpected character after line continuation character. So this is not the way to do it. I actually need this to be like this and run it. That's the way. It needs to be in the string fed to the print loop, print function. All right, we've learned a few things that are preparing us to do much cooler things. So while loops are really pretty cool. And right now, a while loop, by the way, we call these forever loops because true is the default in Python. You've heard that before. And so if you say while true, then that's just true. It's true forever. It's true until you send it a break command, which is another reserved word. And so if we go down here and we look at a while true loop, using the while true loop, forever loop, loops forever, if I go down here, a break statement is a condition and that will cause the while true loop to end. So here, while true, print write forever unless there is a break. I want to show you something. What if I'm going to run this and it did it? If you take this break out, if you try to run one of these, I'm going to comment it out. I want to run it. Aha! I want you to see, look at this. Look at this. You know how fast Python is? There's millions of these here now. It's just infinitely putting them out. It's going on and on. Look at the little thing building up, building up. It's just running and running and running and running. If you do this, you have to break the kernel, hit the stop button. The other thing, I don't know if you noticed it, but over here where it says 37, because this is the 37th thing in this notebook that I've run, it had a little star asterisk right there, which meant that the Python engine was busy. The other thing you might have noticed is up here by the Python 3, it wasn't an open circle, it was a closed circle, which meant the Python processing engine was fully occupied. And I could not have done anything else with this notebook while that was running because I had written infinite code that was hogging up the Python engine. So I had to break it and I had to start over. So now I can come back and I can fix my code, save it, and run it again. And there you have it. Now it's fixed. But that's something you have to think about in terms of your coding, is that without the break, a while true loop runs forever. Just since you can have conditions that would cause it to break, but otherwise it just runs forever. And an awful lot of things in code do that. So for example, when you have a window open on your computer and it has the little close button on it, for example, that window is being run by code in something like a while true loop. It's just on waiting for that button, the close down button, to be clicked. Otherwise, it's running and updating its contents and making them available to you in the operating system. That's how Windows in your Windows operating system or Mac operating system are actually written in a coding sense. They're written in a while true loop. So here, review the number, code, then run, queue. The question is, what caused the break statement to run? So if we run this, and it says guess a number 1 to 5, I'll say 3. Guess a number 1 to 5, 2. Guess a number 1 to 5, 4. Guess a number 1 to 5, 5. And it broke. Because when the number guess equaled the secret number, it told me yes, and it ran break. So that's the condition that caused this thing, the loop, to close out. like we said about the while true loop running a windowed application inside of your laptop or desktop computer, and someone clicks the close button, there's some code there with an if statement that says, well, if they click the close button, then break, and it closes down the window. So very similar. Here you see while true, enter the weather. You can run this example. If you write something that starts with Q, then it's going to detect the quit and it's going to break. There you go. So I think you can read through these and understand what's going on. Task 6, get a name forever. So in other words, there's going to be while true, and it's going to ask for a name. If this name exists, then it will break. So let's just try this out. So def, create a variable familiar name and assign it to an empty string. So let's do that. Actually, it doesn't say to use a function, so we don't need to do that. We can use procedural programming here. So familiar name equals, it's just a blank string.
Sorry, could you...
And now let's do while true. Ask for user input for familiar name. So familiar name equals input. Please input a familiar name, friends, family, use. There we go. Just reading through the instructions there. If familiar name is not equal to blank string, break. That will break our while true. And then we will say print hi, comma, familiar name, run. Now, remember what I said earlier? You may not have noticed, but here's the little star. Here's the full circle up here. And if I hover over it, it says kernel busy. This is completely filling up the Python engine on my machine at the moment. And now, if I put something in here, I can say Jim, and hit return. And notice it continued executing the code. It finished. The Python is now idle. Python kernel, it tells me the order in which it was run on the page, and it says hi Jim down here. So there you have it. Another thing we do with loops sometimes is we can go up or down on some kind of variable. So we can come over here and increase the number of votes or decrease the number of votes. And there are a couple ways to do that. So you can see here votes equals 3. And then what's going to happen is votes is going to change because we say votes equals votes plus 1. And when you say votes equals votes plus 1, that's going to take whatever the number in votes was. If Python figures out that it's an integer or a number it can do math with, it will add them together. And now votes is going to be 4. And then down here, there's another way to do incrementing or decrementing. You can use plus equals or minus equals. That's like a shortcut for doing votes equals votes plus 1. So down here you see votes plus equals 2. So that is going to add 2 more to votes. So what's going to happen is we should see votes. We're going to see a 3. We're going to see a 4. And we're going to see a 6. And there they are. And then down here, similarly, we can do subtraction. We can do minus equals. Now at present, votes is 6. So if I come down here and run that, then I see that votes was 6 and now it's 5. What if I run it again? Now I get 5, 4. And again, 4, 3. Interesting, huh? Seat count, we can run the code here. So while seat count equals 0, while true, print seat count is whatever. Seat count equals seat count plus equals 1 and up to 4 and then break. So we can run it and it instantly went through 0 to 4. How about that? And then it broke and it stopped the loop. You see how fast it was? It was able to process a whole bunch of stuff very quickly there. All right, here's another seat count code, and notice seat count hard, soft, medium. It's going to tally the seats, enter type of seat hard, soft, and then seat count. If seat count is greater than equal to the number of seats, so 4 seats, then it's going to say the seats are full. So let's go through. We're going to take dynamic options here. So I can do hard, I can do hard, I can do hard, and then I can do soft. And now it tells me seats are full, and it has 3 hard and 1 soft. So there's a lot going on right there. We are starting to build much more sophisticated code. I want you to be able to read through the code and see things. And remember, like here, if seat type dot lower dot starts with. So Python works from the inside out. The very first thing was the lower. So in this case, it's going to take the input from the user, seat type. It's going to convert it to lowercase. Then it's going to check if it starts with E. So that, if you don't remember from an earlier tutorial, that is method chaining. So many of the things we've been doing are actually coming out here. Here you see that character feed for a line feed, and that's what's causing down here a little space before it says seats are full. So we've got a lot going on. We're able to make fairly sophisticated things pretty quickly. Down here, this is very similar to what we just did. Input, exit with finish. So here, this is a very similar loop to what's up here, except you're going to do shirt count using sizes small, medium, large. And instead of having a number of seats, you're going to tell them to type exit when they're done, and then you're going to type out to them. You're going to report the total numbers of small, medium, and large sizes. So I think you can do that. And when you see this run tests, you always test your code. Make sure it runs the way that you wanted it to run. Now what's happening here is you're going to take your same code for shirt count. You're going to paste it down here, but this time you're actually going to calculate a cost. You're going to get the count of the shirts. So however many there were, just like up here, we were able to say, well, look, there were 3, etc. And you're going to multiply it times the price, and then you're going to report the total costs of the different shirts at the different sizes. So I think you can do this too. This is a lot of fun, and you can see how we're starting to build up the necessary capabilities for some sort of mobile or online store logic, or could even be a device that would do this if we were to build a device like a cash register or something like that. Boolean operators can be used in while loops. That's actually true also. So we've done loops using true, but actually we can do them other ways. So here, while greet count is greater than 0, that's a Boolean test. And so if greet count gets down to 0, it's gonna run out. So I can do that. I can play with this a little. I can put this up to 8, and then I can run it, and I can see that it works. What if I say, what if it's just greater than 1? And I run that, and I can see that that works. So it does a quick countdown, and it says ignition. So I can tell that this is working. This loop ends itself when the condition is no longer true. That's very useful also. So I can write the while loop using a while true and then use a break, or I can just write a condition straight into the while loop definition. And if the condition becomes no longer true, then the while loop will end automatically. So that's pretty cool. The comparison operators work too. So if you noticed up there, we had a comparison there, create the animal's names program, run the test, use while to get the user input animal name of 4 animals. So give me names of an animal, if exit in all animals. So here you can see of 4 animals, use a counter num animals in the while loop condition, append the names to a string variable all animals. User can exit by typing exit. Or type exit. Okay? Now, we're going to put it into all animals. If exits in all animals, it's going to end. Num animals plus equals 1. It's starting at 0. And what did we want? Elif num animals equals. Actually, why don't we just why don't we do this a different way? We just learned conditions, right? We don't need a while true. We need while num animals is less than 4. We want our loop to run while animals is less than 4. When it hits 4, it's going to end and print. So let's just try that. Dog, crow, cat, mouse. They're there. So we actually, here we had a combination of the things we've learned. We had a condition in the while definition. We also had a break statement. Either one of them could cause it to end. We can test that. Dog, crow, exit. There it is. How about that? So there, bonus, print no animals if animal name is empty after exit the loop. So that's easy. We would just put an if statement testing if all animals is empty, and then we'd have an else, and we could handle that. So I think you've got all that. You could finish that out. And you can see we're really getting to some strong capabilities here. So next thing, while Boolean string test. So here, while fname.isAlpha equals false. In other words, until somebody puts something in, we want this loop to continue. Student name equals input, and it's going to ask for that. So if you run this and you put in a 5, it's going to prompt again. If you put in a period, it's going to prompt again. If I put in a T, it will move forward. See how that worked? Because isAlpha is looking just for letters. No numbers or punctuation. So it ran on through it, and then it ended the loop because it had this condition. Check this. If I take the equals false out, it just checks for true. So now, student name is alpha. Well, its student name is a space. So I actually, here, I could do none. None type has no attribute. That's true. It has to be a string. So let me see if I can make that work. I can start by making this a period. Is alpha, it's going to resolve is alpha. Yeah, so actually, I guess I have to use it this way. There. So when it's not true, then it's going to force it to have letters this way. While using, but notice you can test that out. Test it out. I want you to test things as you go through here. There's a lot going on in Module 4. Get used to it. Play with it. Play with the code. Run some tests. That's what I'm doing, running tests. create variables, int num, long num, as an empty string, get user input string of digits. So you're going to use an input prompt and tell them to put just digits. Create a while loop that runs as long as the input is all digits. If they put a letter or punctuation in, it's going to end. Inside of the loop, add int num and log num. Get user input for int num again inside the loop. After it exits, print the value of long num. I think you can work through that. You can work through that and post your questions and answers, and the team can help you with issues as they come up. And then finally down here, if I run this last one, I just ran it. I see the Python interpreter is busy. I see the asterisk here. This thing is not ending. While count is greater than 100. Count equals 1. Count is never going to be greater than 100. So I got to hit the stop button up here. I got to come down here and think, well, maybe what I really meant was less than, say, 10. Now I can run it, and I see I instantly get a result. Well, I can even put 100 here, and I can see Python can instantly run. Look how fast it is. It runs that multiplication table, creates it instantly. So you can do all of that, and I think this is a lot of fun rounding out this part of Python Absolute Beginner, getting ready to do Module 5, which doesn't have a tutorial because it's all just required code for Module 5. And you're also ready now to do the practice and then required code for Module 4. So happy coding. Reach out when you run into trouble and difficulties. Post them, document them. That is a skill too. Put them into the discussions so that others can benefit from helping you and you can benefit from helping others.